Don here in Florida. Today we're going to go ahead and try to make a lock for this bandsaw that I picked up at the flea market. I did a series on when I picked that up, how to true it, get it adjusted, make it work. But the one thing that always came back and kind of bit me was the movement of the saw. When I'd move it from one place to another, the lock that it came with just didn't work well. So I've come up with another solution. We're going to go with that, and today we're going to go ahead and try to build that. So let's get to it. What we have here on this 4x6 bandsaw originally was this pin that inserted through the frame like this, and this was supposed to keep the bandsaw from canting up. Well, this arm right here is a really solid point, and I thought what I'd do is I'd create a block that would move in and out to keep that arm from moving. So we're going to try this. How we're going to do it is we're going to take this plate, we're going to lay it up in here, and my original thought was to have that centered so I could have this teed off here, but in the end I decided we're going to move this all the way back like this to get in as close as we can to that, so that I don't have to build up a bunch of extra metal here to hold that. And this is going to slide in and out. We have a 1/2 inch gap here, so basically we're going to have a block here that slides in front of this to stop the saw from coming up, so that'll block it up from coming. And I want to make this as solid as possible. Alright, so we got a piece of 1-inch bar stock in here, and we're using a 1-inch end mill, and we're going to see if we can get to full width of that. We're probably going to have to do this in 2 passes, so let's take a look at that and see what happens. Done all right. Much nicer. Yeah, see those edges are beveled off, so you can only get the top flat surface. That has a severe bevel right there, so I don't know where this bar stock came from. Get a lot of stuff out of the scrapyard and try to make do. And this one here, that one there has a lot of milling to do. Alright, so I came off the milling machine. I could have spent a day and a half milling this block down to size, so what I decided to do was just cut it to size and then clean it up on the mill. I need a 1/2 by 1/2 block because that's the piece that's going to move in and out and give us our locking action. So I come over here on my handy dandy Craftsman converted vertical bandsaw here with a cheap eBay blade on it, and we're going to cut this to size. Alright, so we should have a piece pretty darn close to 1/2 by 1/2. There we go. She's sitting right where I need her. Alright, we locked our Y axis in at 0. We're dead center in the middle of that piece, and what we're going to do is we're going to take a groove out of there 1/2 inch wide by 1/2 inch deep for this to sit in, because this is going to be our bolt that moves back and forth in there. I got to bring this up a little bit here on the Z axis, so we'll 0 that. I just touched off on it. And we'll bring it up, see how she feels with, let's go 15 and see how she feels. That's a roughing mill on there, so hopefully she doesn't kick and punch too much on us. last shot here. Let's see if we get that line. That's half right there. We're gonna add a little extra because the locks tend to move it a little bit. And let's bring her in. That roughing mill's doing a real good job. I'm not going to do anything past the roughing mill. I don't need to have this really tight. As a matter of fact, so we're back on another part now. We're going to turn the end off this Allen screw real quick here. We have to do a couple of Allen screw modifications we have to make for the project, and then I'll show you why. So let me come up here and set my DRO to 0. All right, I'll zero that out. There we go. Get that rocket and rolling here. We're going to take 90 thousandths off of this. I like these GRs because they're offset and you can get right in close to the chuck and do real nice close work. Now, I can do a lot of stuff with them. I can form with them. I can chamfer with them. I can do just about anything except cutoffs with them. I think we got that about what we wanted. That tight tolerance. This just kind of means you can knock it out and just enjoy the ride, you know, on the lathe here. Isn't often you get to just get in here and turn stuff and play with it and not have to worry about being right, and I hit it right on, so I better shut my mouth right. Kind of at I was cutting that out, I think, when we left off, and or I was squaring this. I can't remember. I finished this off once I got off the mill on the belt sander. I just rounded the edge a little bit so it would fit in there nicely, and it would be just perched below that point here. So that moves very nicely now. And this is going to go onto this plate like this, and this is what's going to create our locking action. So of course we're going to have the stop out here. What we needed was a stop for this because we're going to put a groove in here, so this can only come out so far and stop, so it'll groove into there and lock like that. So we're gonna have a hole there that rides into, and that'll come out like that. This here is for our click point because we want to click in and out. We want to stay in position. We don't want the movement of the saw causing us to vibrate and move out of position. Now there are screws you can buy that you put in here that you can just drill a hole, tap it, and you know put a counter bore right there, and that'll just click in and out like that. But to get it to the size I wanted, the screw itself is actually wider than the part, so we have to make our own. And given that we don't have a lot of space in here to play with, we're going to have to make some modifications. So keeping all that on a magnet. We have a light spring here. We don't need a heavy spring. This is just to keep it from vibrating out of position. The stop here will stop it going all the way out, and of course coming all the way back in. I'll put that back there. Of course, coming all the way back in, you know, to stop here, so it has a stop either way, yeah, which is good. And there we go. That's a little bit better. So we got about a third of that ball sticking out through there. Hoping I'm catching that on camera. So let's go ahead back over here. Okay, so this is going to sit over that line right there, and it'll allow us to determine where to put the countersinks. Getting away at this piece here. This is the actual lock piece that is going to go on the slider. That's going to lock that. It's going to block that saw from coming up. It does take a little bit of hand massaging. It has to be contoured somewhat because of the form of the saw. I contoured all this area out pretty much. I still need to get some clearance on this point here, so I went ahead and set it up here in the in the vise, and we're going to go ahead and clearance that right now. So let's get to that. Alright, that isn't too bad. It's going to take a little bit more contouring than that, but we need to check it over on the saw right now. These are our main parts here. This is the part that's going to slide. I got the pin in there already. I did that when the camera was dead. We'll get that out right now because I don't have the slot for this. So this is going to sit on here like this, and that's so it'll sit in there like that. This piece here is actually the block, and I don't know if that's getting this. This is the block that sits down in here like this. Okay, and that has to be contoured to kind of miss that area right there. Additionally on this, I left some area on the top here to get a finger hold so that you can slide that in and out easily. So it's going to sit down in here like this and act as a block, and when the saw is down like this, I'm hoping that's all on camera. Okay, it'll sit in here like this. All right, and it looks like we've created the clearance we need now for that to open and close. And I had to bevel this off on the back because the saw goes out at a slight angle, so I beveled that away from the saw. And if you look in here, angle, see, I had to make some clearance to get by there. So hopefully when the saw opens now, and we can always come back and adjust this as needed, it'll clear that lock. And then when we pull it out, it's going to come out half an inch. It'll create a barrier at this point so that this just can't open. So let's go ahead and finish this up. We got a and let's check that again. Oh yeah, perfect. I don't even know why I was second guessing myself. Okay, we're back. We're gonna go ahead and tack this together real quick. There we go. I'm gonna flip it back over and get the other side. Even though it doesn't look like it, you get much better penetration. Especially when you have flat surfaces being mated together. So use my tapping block here because I'm kind of off at an angle. This piece here, I didn't bother to show the welding of this. I worked with a guy that used to say, we do it right because we do it twice. Well, this was one of those occasions. When I did the original weld, I ground out the fillet area thinking it would be strong enough, and as is, it wasn't. So I re-welded it and then contoured out the fillet area here to give it a nice strong connection point. When that arm kicks out, it causes this to twist. So what I was worried about was putting too much twisting motion on there, too much stress. And after I cleaned up the fillets, of course I had to contour this to meet the side of the saw. This had to be contoured, everything had to be aligned so it would line up with the contour of that saw arm as it came off of there. And then another thing I did was I I opened this up just a little bit so that fillet weld could sit down inside of there, so we have a nice clean movement. All right, back for final assembly. Came out not too bad, I'd say, and it's going to be a real quick assembly. There's not much to it. We've been through this like a million times. Ball, spring, a little dab of Loctite on these threads, and get that in there. And that should do that. Let's test our fit. Oh yeah, beautiful. Click, 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 click. Just like that. And then we'll go ahead and put our screw in here, our stop. We'll dab Loctite. Alright, I'm going to use some of this sticky chain lube here. Just not going to get too crazy with it. A little bit in the groove and on the ball. And then across the top. That's about it. So we'll reinsert that. Nice. And our screw. And I'm going to take it down to the stops and then just back it up a little bit. Get that out of the way. And then we'll give it a little test run here. Oh yeah, click, 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 perfect. All right, let's put it on the saw. All right, let's check it out. See what we got. Lift that up just a little bit. All right, let's check it out, see what we got. And it does what it's supposed to do. Clicks back in, so I know it's not going to rattle out on me. That's it. Nice tight fit. All right, so we got this all together. It's working the way we expected it to. Realistically, I guess I just could have gone to the hardware store and bought a dud bolt and stuck it on there and maybe welded a nut on the end of it. That would have been a whole lot easier now, wouldn't it? I got the feeling it probably wouldn't be as durable in the end though, so we decided not to go that route. No matter how you slice and dice it, this locking assembly is going to work out far and away better than that pin that they put in there at the factory. That was just a bad deal from the get-go. And again, from Florida, Don out.